Now, let's look at the quantum of the C-quark decay. First, we'll look at electric charge, spin, and weak charge. So first, let's look at the electric charge of the C-quark. So we have a generic U-quark, which has two T rishons that each have a charge of 1/3, giving us 2/3 for the generic U-quark. And on the neutral boson, scalar boson, with a flavored anti-T, anti-T, and the particle-antiparticle pair, there's no contribution to the electric charge. And if we look down at the anti-C quark, then we'll see that we have the opposite quanta of electric charge. Now, if we look at the D quark, where we have also a generic U quark giving us 2/3, but then we have a boson minus composed with a anti-flavored V quark and anti-T quark, and with a minus 2/3 on the anti-flavored V quark and a minus 1/3 on the prime T quark, giving us a -1 to reverse the 2/3 on the U quark into a minus 1/3, which is the appropriate electric charge in the standard model for the CD quark. And then on the W plus that is carried away, we have 2/3 on the flavored V, and on the prime T, we have 1/3, giving us a 1/3 charge, of course, carried away on the boson plus. And the particle-antiparticle V pair contributes no electric charge. So let's look at spin. And so, on the two T quarks, we have opposite spin, so the spin contribution would be given by the V quark, and in this case that is 1/2, plus 1/2. And then the spin on the boson, neutral boson, and the particle-antiparticle pair are opposite spins, and so make no contribution. So the spin on the C quark is plus 1/2, or right-handed. And of course, again, it's the opposite for the anti-C. Now, if we look at the S quark, then we'll see that the U quark, there's been an exchange of V rishons, so that now rather than a positive spin, a right spin, we have a left spin. And the other two T rishons still cancel, so now the spin on the generic U is left-handed, or minus 1/2. And here we have on the boson minus scalar, we have no contribution to the spin, so the spin on the S quark will be minus 1/2. And if we look here, we can see that the spin on the V anti-V pair sums to 1, and there's no spin on the scalar boson plus, so the spin for the entire W boson is spin 1. Now let's look at the associated weak charge. This was a right-handed U quark, and we know that the standard model predicts that right-handed particles will have a weak charge of 0, And if we look, we have a minus 1/6 and a minus 1/6, which is minus 1/3 plus 1/3 will give us 0. And we see that there is no weak charge contribution by the neutral boson or the particle-antiparticle pair. And again, we will have the opposite situation for the C quark, but since it now is a left-handed antiparticle, we again have no weak charge. Now, we have a left-handed generic U quark, and left-handed particles do carry the weak charge, and we can see that with the switch of the V rishons, we now have weak charges of 1/3 plus 1/3, which is 2/3, and minus 1/6, which gives us 3/6. So we have a weak charge of 1/2, which is what is predicted by the standard model for the left-handed U quark. But this is not a left-handed U quark. It is a S quark. And so when we look at the boson minus, we'll see that it contributes a minus 2/3 and a minus 1/3, which is a minus 1. And then when summed with the plus 1/2, we end up with a minus 1/2 on the S quark, the left-handed S quark, which is predicted by the standard model.